Welcome back to Inorganic TUTOR'S Institute. In today's lecture, we are going to look at how we can solve this particular problem, okay? So this is basically some coordinate geometry problem that I came across and I said, let me solve it out. Okay, so this is the problem. A point A of coordinate 1, 2 is one vertex of a parallelogram, okay? You know, parallelogram have four sizes, right? That's A, B, C, D, right? And the side AB lies on the line 2y equals x plus 3, and the diagonal BD lies on the line 3y plus x equals 17. Now, the question is saying that if line AD is equal to line BD, then we should find the coordinate of C and also find the equation of the perpendicular bisector of AB. So we have been given the illustration, okay? So this is the illustration of whatever is being said here. This line BD, AD equals what? BD. That's what the question is saying. Okay, so now we want to find the coordinate of what? C here. So let's say this coordinate is named P and Q. Okay. And we have been given the coordinate of what? A. So let's bring it here. A of 1 and 2. Right? So we want to find the coordinate of C. But before we can do that, we have to do some kind of calculations before we can get the coordinate of C. So first of all, let's say that, so solution, let's say that this right here, the triangle, this angle D. Okay, so if angle DBA is equal to theta, then first let's find the coordinate of B and D. So we have to first find the coordinates of B and D, right? So we want to find the coordinate of B and D. But also note that from the figure above, we can say that triangle EAF, we can see something from there, right? You can see that tan gamma is equal to tan into theta plus what? Beta, right? So let's call that equation 1. So tan gamma is equal to tan theta plus tan beta, right? So I just introduced the tan to both sides straight off because you know that gamma is equal to theta plus beta, bro, from this triangle EFA, right? So if this is equal to this, then you can introduce tan to both sides. Then you have tan gamma equals tan into theta plus beta, right? So if that is true, then let's try to also say that this tan gamma will be equal to, we can expand this, right? So if you expand this, then you're going to have tan theta plus tan beta over 1 plus tan theta plus tan beta, right? If you expand this from trigonometry, when you expand this, you have tan theta plus tan beta over 1 minus tan theta times tan beta, right? So that is what we have. Now let's go away with this question so that I hope you've written the question down. So now that we have this, now don't forget that tan beta is equal to half. That is from here. Okay, that is the gradient of that beta, right? So we can say that from 2y equals x plus 3, that is y is equal to half x plus 3 on 2, right? So that is where we are getting tan beta equals what? Half. That is the gradient for that. Okay. So once we have that, then the next thing we have to do is that we have to say that also from triangle EBJ, from triangle EBJ, this is J, okay? From triangle EBJ, we can say that beta plus 180 minus beta plus 180 should be equal to what? 180. That is from here. This is on a straight line, right? So beta plus 180 minus theta from here plus 180 minus what? Alpha. So that is what we have. So this one, when you simplify this, you're going to have 180 minus theta equals alpha minus what? Beta, right? So this as well, we can expand this. So we can say that tan into 180 minus theta is equal to tan into alpha minus what? Beta. Okay, so let me go away with this. But don't forget, I'm writing this down. Tan gamma is equal to tan into theta plus beta, right? So going away with this. So let's expand this. When you expand it, it's going to have tan 180 minus tan theta equals tan alpha minus what? Tan beta, right? So you know that tan 180 is what? 0. So we have negative tan theta equals tan tan into alpha minus beta, okay? Tan into alpha minus beta. And you know that this can be expanded to be have tan alpha minus tan beta all over 1 minus right? So we have minus tan theta, right? So this is what we have for this expansion. Okay, so we are going to use this very well. So it means that we have to find tan alpha, because we already know tan beta to be what? Half. We have to find tan alpha so that we can know this tan theta, right? So what do we do next? We know that from here, we can note that, right? So let's try to go away with this diagram, or yeah, we can do it here. So we can say that from 3y plus x equals 17, we can say that y is equal to minus x over 3 plus 17 over 3. This implies that our gradient, which is tan alpha, is equal to minus what? 1 on 3. Okay, so we are going to substitute that in here to find tan theta. So let me go away with this. Okay, so this is going off. Okay, this is going off. So we're going to have minus tan theta equals minus 1 on 3 minus tan beta is 1 on 2, right? So all over 1 plus minus 1 on 3 times 1 on 2, right? So this is basically equal to negative 5 on 6 over 5 on 6, right? And this is equal to 5 on 6 over 5 on 6, right? And this is equal to 5 on 6 over 5 on 6, right? And this is equal to negative 5 on 6 over 5 on 6, right? And this is equal to negative 5 on 6 over 5 on 6, right? And this is equal to negative 5 on 6 over 5 on 6, right? And this is equal to -1, right? So we can say that minus tan theta is equal to -1. So this implies that tan theta is equal to what? +1. Okay, so once we have tan theta to be +1, what are we going to do? We're going to substitute it here, right? So let's go ahead. So where is, okay, so let's try to go away with this. So let's say that tan gamma is equal to tan theta plus tan beta over 1 minus tan theta tan beta, right? So now we can say that right? So we can say that tan gamma, we are going to look for tan gamma because we know tan theta now, right? So we say that this will be equal to 1 plus half over 1 minus 1 into what? Half, right? And that will be equal to 3, right? So we have tan gamma to be what? 3. Okay, so once we have tan gamma to be 3, let's try to put that here. So we have tan gamma to be what? 3. Okay, so we have obtained tan gamma to be 3. So what we need this? The next thing we have to do is we have to find the gradient of what? Line AD. So, okay, so meaning that the gradient of line AD is what? 3. The gradient of line AD is what? 3, right? So we can say that we can say that the gradient of line AD is 3. Okay, so once we have the gradient of line AD, then we can say that the equation of line AD is given as hence the equation of line AD is given as y minus 2 to be equal to 3 into what? X minus 1, right? So now we can say that, we are using AD, right? We know the coordinate for A, so that is what we are using as a point, right? Y minus 2 is equal to 3x minus 3. So we have y is equal to 2 plus 3x minus 3, right? So this means that y is equal to what? 3x minus 1, right? So this is the equation of line what? AD. So y is equal to what? 3x minus 1. Okay, so once we have that, then it means that we can solve this equation and this equation, right? To find the point for x and y. Okay, so let's solve that simultaneously. So I'm taking up this part. So we have this one going off. So we have this one going off. So we are going to solve y equals 3x minus 1. Let's say that that's equation 1. And then 3y plus x equals what? 17. This means that y is equal to minus x over 3 plus 17 over what? 3, right? So we're going to solve this and this simultaneously, then we obtain the coordinates, right? So when you solve this simultaneously, you have x equals 2 and y equals what? 5. Okay, so once we have these 2 points, then we can say that the point of D, of which is here, will be hence the point of D is what? 2 and 5. So we have here to be 2 and 5. Okay, we have here to be 2 and 5. So we have used this equation and this equation to find the coordinate, solve this and this to find the coordinate of what? B. So to find the coordinate of B, we solve 3y plus, of which we have here to be y equals what? Negative x over 3 plus what? 17 over 3. So we name this equation 4. Then together with 3, that's 2y. So that's going to be y equals what? X over what? 2 plus 3 over what? 2. So name this equation 5. So we're going to solve 4 and 5 simultaneously to find the coordinate of what? B. So when you solve this very well, then we can say that our x will be equal to 5 and our y will be equal to what? 4. Right? So that is the coordinate of what? B. So the coordinate of B is 5 and 4, and that is here, 5 and 4. Okay, so we have used this equation and this equation to get the coordinate of D, and we use this equation and this equation to obtain the coordinate of what? B. So now we know A, we know B, we know D. What is next? C, right? So we are approaching the headline, right? So now, can I go off with this? So I'm going to go off with this here. So going off with this, you can see that dash. So let M be the midpoint of line BD and also line AD. Okay, so if that is true, then we can say that the midpoint will be equal to this and this, right? We're going to have 5 plus 2 over 2, and then 4 plus 5 over 2, right? So we say that the midpoint will be equal to what? 7 on 2 and 9 on what? 2. Okay, so that is the midpoint of line BD and also line AD. So once we have the midpoint, now we have to find what? The coordinate of what? C. That is very simple. This is all we needed to find the coordinate of what? C. So now we can say that the coordinate, as we said, let's C of P and Q be the coordinates. Be the coordinate of what? C, right? So we're going to say that P plus 1 over what? 2 should be equal to 7 on 2, right? And Q plus 2 over 2 should be equal to what? 9 on 2, right? So that we can find the coordinate of C. So when we do that, then we are going to have the P to be equal to, when you cross multiply, we're going to have 14 equals 2 into P plus 1. Then this implies that our P, when we expand the bracket, we're going to have 2P plus 2 is equal to what? 14. So this means that our P will be equal to what? This minus this is 12. 12 divided by 2 is what? 6. So we have the P to be 6. And then we have q plus 2 over 2 should be equal to 9 on 2. So when we cross multiply, then we're going to have 18 equals 2q plus what? 4, right? So we have 2q equals what? 12. That is 14, right? So we're going to have our q to be what? 7, right? So that means that our coordinate of C will be 6 and 7. So let's come up here. So that's the coordinate of C is 6 and 7. Okay, so that is the coordinate of what? C to be what? 6 and 7. So we have here, now we can say that the coordinate is what? 6 and 7. Okay, so we've satisfied the first part of the question. So to find the equation of the perpendicular bisector of line AB, then first we have to find the midpoint of line AB. So then first we have to find the midpoint of line AB, right? So that is the second part of the question. The midpoint, the equation of the perpendicular bisector of line AB. Then first we have to find the midpoint of line AB, right? So that is going to be, so we are letting M be the midpoint, okay? So M should be equal to what? 5 plus 1 over 2 and 4 plus 2 over what? 2, right? So we say that the midpoint of line AB is 6 over 2 and what? 6 over 2. So that's our midpoint is equal to 3 and 3. Okay, so this is what we are going to use as what? The points. Okay, so we have this. What do we need this? We need the gradient, okay? But once it is a perpendicular bisector, it means that the gradient will be negative reciprocal, right? So this here is going to be negative reciprocal. So the gradient of line AB is going to be negative 1 over what? Half, right? We know that the gradient of line AB is what? Half. But since it is perpendicular, it's going to be negative 1 over what? Half. And that is equal to what? Negative 2. Okay, so once we have that, then the next we have to do is to produce our equation, right? So we can say that the equation of the perpendicular bisector of line AB is equal to y minus 3 equals 3 in minus 2 into x minus 3, right? So we have y minus 3 equals minus 2x plus what? 6. So we're going to say that y is equal to minus 2x minus plus 6 plus 3, right? So we have y equals minus 2x plus 9. Okay, so this is our equation of the perpendicular bisector. So let me conclude here. So you can say that that's the equation of the perpendicular bisector is minus 2x plus 9, or y equals 9 minus 2x. This and this, there is no difference, okay? They are all the same. Okay, so if you have a parallelogram, okay, Parallelogram have four sizes. Okay, we have A, B, C, and D, right? So if you have to find the coordinate of any other, you have to look at the diagram, look at how it's going to be. This is a line, and this line, okay, line AB is making an angle of 90 degrees here. So right, so that's why they are saying that equation of the perpendicular bisector, right? Meaning that it is making an angle of 90 degrees. So if it is that, then it means that the gradient is going to be negative reciprocal of what? The original gradient. And that is going to be negative 1 over what? Half. And that is negative 2. So we use that gradient and the midpoint of line AB to find what? The equation of the perpendicular bisector. Okay, that is very simple. Thank you very much for watching. I really appreciate your time. Please, if you really appreciate this lesson, don't forget to spread it to your friends. Let them also have uh, a joy of it. Until the next video, keep learning and stay inspired. Bye-bye.